Okay, let's do this problem here. So most receiver allows the user to connect to remote speakers in addition to the main speaker. At the instant represented in the picture, the voltage across the speaker is 6 volt. Okay, this volt is 6 volt. Determine the equivalent resistance of the two speakers. So these are the speakers here. So this speaker is R1, and this speaker has a resistance R2. So you can see that from the picture that they're connected in parallel. You see that, right? So what I meant by parallel is this. In parallel, the current divide up, right? So this is your current. Current goes this way. Suppose this is your I current. Then some of the current goes from here and some of the current goes from here. So you can call it, you know, I1. This is I1 current, this is I2 current. Meaning the current divides up. So what I meant is this. So this is the voltage, right? Suppose this is current I. Okay. Then I divides into two parts. This part and that part. Okay. So it goes from here. Okay. Then comes back and returns to the negative terminal. Similarly, this guy goes from here, goes through resistor R2 and come back to the negative terminal again. So this can be written as this. This is the simplified version of this picture. Okay. Now these resistors are in parallel, right? Because the current divide up. When the current divides up, this is the rule of thumb. Okay. When the current divides up, then that circuit is parallel. It's that easy. Okay. It means these two guys are in parallel. How do you find the parallel resistance? Now equivalent resistance, meaning you want to replace both of these guys by one resistance. Then what is the value of that resistance? Remember, when the resistors are in parallel, then so the equivalent resistance will be less than each of them, less than 4, less than 8. So if it is less than 4, obviously this is less than 8, right? So let's see. If you do that, my claim is your RP will be 2.67, which is less than 4, obviously, which is less than 8 also. So the question is, how do you get 2.76, 2.67? How do you get that? So meaning you can replace these two guys by one resistor of a smaller value to get the same effect. Okay, so how do you find RP? To find RP, you have to use this formula because the resistors are in parallel, right? So how do you get this one? Now this is 8, now this is 4, right? You have to make the denominator and numerator same. Numerator multiplied by 2, denominator multiplied by 2. Then your denominator are same. So 4 by 2 is 8. So which is equal to 8. Now in that case, you can add the numerators, which is 2 times 1 is 2, plus 1 is 3. That's your 1 over RP. See, this is your 1 over RP. 1 over RP is 3 over 8. And then how do you find the RP? If your 1 over RP is 3 over 8, what is your RP? Guys, help me here.
2.67.
So You just multiply, then RP is 8 over 3, right? Your RP is 8 over 3. Okay, 8 over 3. Because if you want to find the RP, you have to take the inverse, right? So 1 goes to the bottom, RP goes to the top. That's how you get RP. Similarly, you have to do the same thing here. 8 goes to the top and 3 goes to the bottom, which you get 8 over 3. Okay, so when you divide 8 by 3, you get 2.67, as you said. That's right. Now you can simply replace these two guys by one resistor of value 2.67 ohm. Now the question is, okay, we found the equivalent resistance, right? What is the total current supplied by the receiver? What is the total current? What is the total current? Now you can use the Ohm's law again. V equals IR, right? That's the Ohm's law. Mm. So in our case, R is RP, right? So then how do you find the I? Divide both sides by RP. Okay, so V over RP is the I. Then V is 6 is given here, right here. That's your V. Then RP is 2.67. That's what we figured, right? Then you divide 6 by 2.67, which is about 2.27 amp. Then what is the next one we have to find? We found the total current. B is done. Now C, current in each speaker. How do you find the current in each speaker?
I was going to say it would be I1 equals V over R1, and then I2 equals V over R2.
Exactly, because yeah, so because if this is the V, right? This is the V, right? Then what is the V between these two guys, these 2 points? The 6 again, right? Because see, this point is effectively this point, because they are simply connected by wire. Wire is practically resistance-less. They don't have resistance. That's why when you connect by wire, meaning these 2 points are exactly same point. So similarly, these 2 points are exactly these 2 points. These 2 points are exactly same point because they are connected by wire. There is nothing in between. This is simply a wire. Meaning this point is exactly same as this point. This point is exactly same as this point. So what is the voltage between these 2 points? 6. So this point is this point, right? This point is this point. Then what is the voltage between these 2 points then? 6 also, right? This is also 6 volt. Similarly, this point is, see, this is connected to this guy. So this is connected by wire only, okay? This point is effectively this point. It's the same. So this point is effectively this point. They are the same point again. So since the voltage between these 2 points is 6, the voltage between these 2 points is also 6. Now, how do we find the current? Current is V over R, right? So meaning in this case, I equals V over R. Same formula can be used here also. We can use here and here. So in this case, let me call this I, okay, R1, right? So if it is R1, then you have I1. This is I, by the way. I1 equals V over R1. So which is 6 over, what is your R1? Help me here. 8. That's your I1. Similarly, you can do I2. I2 equals V over R2. In that case, it will be, the I2 will be 6/4. That's your I2. So that's the current in each speaker. Now let's do part D here. What is the power dissipated in each speaker? Can you help me here? What is the power dissipated in each speaker?
That P1 equals VI1.
Yeah, you can do that. Yep. So P1 equals, yeah, B1 I1. So in this case, your all B's are same, right? So it's no need to write B1 because this B1 is exactly this B, right? That's why instead of writing B1, you can simply write V. So P1 equals B1 I1. B1, 6, I1, we just figured, right? See, we did that here. The current in each speaker, we know the I1 here, which is what? 6/4. Okay. So that's how you get P1. Similarly, how about P2? P2 equals B times I2. So B is 6 again. I2 is 6/8. Okay, this is what? Yep. Okay, this is, your goal is to find the total resistance. So just look at this, okay? Don't worry about other pictures. This is your problem. So how many resistors do you see there? 4? There are 4 resistors. Now, some of them are in parallel, some of them are in series, right? That's what I can see there. Then just group them, which one is obvious. Okay, group them together. So whatever resistance, let's say, what I meant is this. So out of those 4 resistors, right, can you at least tell that 2 of them are either in parallel or series? Can I say these 2 guys are, these 2 guys, if you take a look at these guys, are they in series or parallel? I need help here, okay? Please.
Series.
Series.
How do you know?
Because they're not, because they come one right after the other, and they're not the.
Okay, that's a very good point. And also, there is an easy way of doing it, okay? So let me tell you. So when the current flows from here, right? Suppose current flows from here. Then the same current passes through both of them. You see the idea? If the same current passes through both of them, then they are in series. Now we know these 2 guys are connected in series. That's why, how do you add them together if we connected series? So RS equals R1 plus R2. That's how you add them, right? If they are connected in series. That's the formula, right? So what is R1? R1 is 220. What is R2? 250. If you add them together, what do you get?
470.
470. Now, you know, this guy is 470. Now you can, next obvious thing you can say is something here. Now, how about these 2 guys? Now let's take a look at these 2 guys. Are these 2 guys, which I circled, are they in series or parallel?
Parallel.
How do you know?
Because because the current isn't flowing through both of them.
Yeah, so the current divides up, right? So suppose suppose some current is right here. At the junction, what happens?
Only one goes through the.
One goes through here, the other one goes from here. Remember, in the case of series, what we said in the case of series?
All of the electrons flow through them.
Yeah, so the same current flow through the both of them. Okay. Now, if it is parallel, the current divides up. If you follow this trick, you never get confused. How do you find the equivalent resistance in parallel? One fact we know about this is our equivalent resistance when connected in parallel is smaller than either of the resistor. So what I'm claiming here is my resistors are in parallel. So, and my total resistance is 130. That's my claim. Why did I do so? Because I'll show you in a second, okay? But does it make sense? It does, because 130 is less than 180. 130 is less than 470, obviously. That's why looks like this makes sense. But we have to make sure this is the right number. Is 130 the right number? If the resistors connected in parallel. What is the formula again? 1 over Rp for the parallel, right? 1 over Rp equals 1 over R1. What is your R1? Help me here.
180.
180, right? R1 is 180. Then what is your R2?
470.
470. Very good. Thank you. 470. Okay. Now, how do you find the? So how do you find the 1 over Rp? So 1 over Rp is just take the. They are not same, right? So you have to somehow take the LCM here. Least common multiple, right? That you did in elementary school. LCM. Find the LCM of these two guys, and so anyway, you can do this right hand side, right? Once you do right hand side, you get some number here. On the right hand side, you get a number n. Then what is your Rp? Your 1 over Rp is n, right? 1 over Rp is n. Then what is your Rp? Rp is 1 over n. From here, your Rp is 1 over n. And that 1 over n happens to be 130. Does it make sense?
Yes.
Now we have two more resistors. We have one more to go, right? So these two guys. Now let's talk about these two guys. Are they in series or parallel? Does the same current flow through both of them, or different, current divides up?
The same current.
Same current. So if the same current, then they are in series, right? You simply add them together. So how do you do that? So 130 plus 110, you add them together, you get 240. So this is the equivalent resistance. Now, if we have to find the current in the circuit, then how much current is there? How is the total current? So now look at this guys. Look at this guy. What is the total current in this guy? That's our beginning, right? That's your real question. This is your question. In the test, I'll give you this circuit. That's the only one circuit I give you in the test. This circuit. This will be in the test. Then I'll be, if I give you in the test, this will be the only picture. Then you have to do all those steps here. 1, 2, 3 steps by yourself using your, knowledge so far you have. Okay. Then after you find the equivalent resistance, which happen to be 240 in our case, if I ask you another question now, okay, what is the total current through the circuit here? What is the total current here? If I ask this question, then can you answer my question? Again, see, so this guy is exactly this guy, right? They're identical. So instead of relying on this guy, now rely on this one, because we have much simplified form, right? So then come down here and find the I. What is I? Using this circuit, V equals IR, again Ohm's law, right? Equals IR. Okay, so here, so what is your B? So you need to find I, right? How do you find I? Divide both sides by R. That gives you I. So what is your V? 24. So what is your R? 240. That's how you get your I. 24 divided by 1, 240. So which is 110. Which is 110 means 0.1 amp. That's your current through the total current through the circuit. Total. I'm saying total. How about this one? Let's do this problem then. Okay. So what is our goal is, if you want to figure out right away the kind of connection they have, then you do that first. Okay. That's your goal. Now this is your picture here. So this is the question I'll give you in the test. This is the question I'll give you in the test. That's all. Okay. Then you have to come up with all those, following picture. This you have to come up with this by yourself. So this will be only one picture will be given in the test. Now your goal is to figure out the total current in this circuit here. How do you do that? So first of all, oh, by the way, the resistors are also represented by this rectangle, right? So this is different from here, right? You have this kind of symbol here, and you have this kind of symbol here. By the way, they are also resistors, because resistors have two symbols. One, the rectangular, the other one, this kind, serrated, like that, right? So now we have four resistors here, R1, R2, R3, R4. R1 is 6 ohm, as you can see here. R1 is 6 ohm, R2 is 8 ohm, R3 is 4 ohm, and R4 is 12 ohm, okay? Now, so let's take a look at least two resistors that you can say for sure that they are in either series or parallel. What is the easiest one to conclude about the connection or combination rather? Which combination?
R2 and R3 are in series.
Yeah, are they in series or parallel?
Series.
Because if the current I1 passes through R2, then same current passes through R3 also. That's why R2 and R3 connected in series. Okay, so when they are connected in series, what is the formula you use?
RS equals R1 plus R2.
Yeah, in our case, RS equals R2 plus R3, right? Okay, so then what is the total? 8 plus 4 is 12. See, that's my total. I did not change anything. I just work on this guy. I just simply work on this guy. Okay. Now my picture becomes simpler, right? So I'm down to 3 resistors from 4. Now look at this now. So which one you can surely say that 2 of them are either parallel or series? Tell me which resistors are either in series or parallel. Which one you can say 100% sure about whether they are series or parallel?
R1 and RA are in parallel.
Which one? RA and R4?
Yeah.
So they are in parallel. Why are they in parallel?
The current splits between the two.
Exactly. So current splits between the two. That's why these guys are in parallel. So how do you find the parallel? So 1 over RP, you have to use this formula for the parallel. 1 over RP equals 1 over RA, right? In our case, 1 over RA. What is the value of RA? 12. Then 1 over R4. Again, R4 is 12, right? Then, so what do you get if you add them together? 2 over 12. 2 over 12, right? Because your denominator is same, right? Your bottom is same for both the term here. 1 of 12, here 12. Then you can simply add the top, which is 1 plus 1, 2. Then 1 over RP is 2 over 12. So most of the time you guys will get confused here and you just simply write the answer 2 over 12, okay? That's not the correct answer. Please keep that in mind. That's most of the time students get confused here. You get 2 over 12 and they think this is the answer. No, that's not the answer. 2 over 12 is 1 over RP. Now you have to find the RP. So how do you find RP? You just flip it, right? So top becomes bottom, bottom becomes top. So RP over 1 equals 12 over 2, which happens to be 6. That's what it is. Does it make sense?
Yes.
Now we have 2 resistors, right? We have 2 resistors. Are they in series or parallel? Again, ask the question yourself.
They're in series.
Because the same current passes through both of them. Okay? So if they are in series, then what is the formula you use? R1 plus R, in this case, 6 plus 6, right? Since they are in series, 6 plus 6. So which happens to be 12. So 6 plus 6 is 12. That's your final resistor. Now your goal is to figure out the current, the total, this IT. What is the total current? That's your IT. This I is, I can simply write I or IT. Okay. So that's your IT. What is the total current in the circuit? Now do not rely on this guy now, because you have much simpler form of the circuit. Then what is the current here? Again, V equals IR or I equals V over R. What is the voltage here? Your voltage is 12, right? It's given here, or you can see it here, right? It's the same voltage. Then V is 12. What is your R? R is also 12, right? So divide by R, which is 12. That happens to be 1 amp. Make sense?
Yep.
Okay, what is the resistance of 10 275 resistors connected in series and parallel? Let's do one more problem here. Your resistor, you have 10 resistors of same value, 275, 275, 275, each of them 275. Now, if you connect them in series, what is the total resistance? Simply, you have to add them 10 times, right? What is 10 times 275? 2,750. So in other words, you can write this way. This is 2,750 ohm. One thing you have to keep in mind that, so when the resistance connected in parallel, then the equivalent resistance should be less than each of them, less than 275. Okay, you should keep that in mind. Okay, let's see whether that makes sense. Let's do the actual problem here. So 1 over RP, if you have 10, 1 over RP equals 1 over R1, 1 over R2, you have to do this 10 times, right? That's what it means. Then what is your R1? R1 is 275, R2 is 275, everything is same, meaning your denominator is 275 everywhere. So how many 1 over 275 you have? You have 10 of them, right? That's why you have 10 of 1 over 275. You have 10 of them. But that is 1 over RP, right? That is your 1 over RP. You have to figure out RP. Then how do you find the RP? You just switch the top and, you just take the reciprocal. We call it reciprocal, by the way. Take the reciprocal of this guy, which is RP, and take the reciprocal of this guy, which is 275 divided by 10. If you do 275 divided by 10, you get 27.5, right? That's how you get RP. Guys, make sense? Question? Comment?
Where does the 1 over 3.64 times 10 to the negative 2 fit in?
Okay, don't worry about it. So, don't worry about it. If you want, okay, this is 1 over RP. Okay, 1 over RP is this guy.
Oh.
1 over RP is this guy. Then RP is 1 over this guy again. It goes in the bottom right here. Then that will be your RP. If you do that, that is your RP. If you do that, yeah, you get this one again. It's the same thing. So either way you get the same answer.
Oh.
Make sense?
Yes.
Very good. Okay, let's do this one here. What are the largest and smallest resistances you can obtain by connecting 36 ohm, 50 ohm, and 700 ohm resistors together? You have to answer 2 questions here. Largest and smallest resistances you can possibly get by connecting these 3 resistors, 36, 50, and 700. So how do you get the largest? You have 2 combinations, right? One is series, the other one is parallel. Which one gives you the largest? Does the series gives the largest, or is the parallel gives you the largest?
Series.
Yeah, series, because in the parallel, the combination gives you smaller than each of them, right? Okay, parallel gives you smaller than each of the resistor, meaning when you connect these 3 guys in series, in parallel, when you connect these 3 guys in parallel, your answer will be less than 36. When it is less than 36, it is obviously less than 50, it is obviously less than 700. Okay, so that's why we have to connect them in series to get the largest. That's what we did here. Add them all together. When they are in series, you add them like this, right? So 36 plus 50 plus 700, it gives you 786. Now to get the smallest, then obviously you have to connect them in parallel. So if you connect them in parallel, so you have to add them together and take the reciprocal of it, right? If you take the reciprocal of it, then you happen to get 20. See, this 20 is less than 36, and obviously this 20 is less than 50 and 700. Now from the resistor, we are coming back to capacitor again, because this is a little bit advanced, not too advanced, but a little bit advanced topic. That's why I put it in the very end of this lecture. Okay. All right, so our goal is, now you have the battery. So how many batteries do you see here? How many cells? You have 2 cells, right? Because minus, so this is, one is long, the other one is small. This is 1 battery. Similarly, you have other battery here. Okay, so you can add lots of batteries. So you have, this is the voltage, right? So total voltage maybe, I don't know, 3 volt. If you have the dry cell, you have 2 dry cells, then 1.5 makes 3 volt. Okay, that's your battery. Now, what are you using this battery for? This battery is used to charge the capacitor. Remember, you charge the cell phone. Okay, so that's what we are trying to do. So you connect this cell phone to the electric outlet. This is your electric outlet. In our case, 110. Okay, in your, if you are charging your cell phone, then 110 is the voltage there. Okay, instead of 3. All right, we are using this 110 voltage to charge the capacitor. Okay, so when you charge the capacitor, then how does it work? So how does the charging process occur? Does it happen right away? No, it takes time, right? But how? How does it happen actually? Does it happen, does it happen like very slowly in the beginning? Very slowly in the beginning and happen fast then after? Or is it very fast in the beginning? Very fast in the beginning, then slowly goes up like this, or it goes like this, straight line like this. Okay, how does the charging process occur? Okay, it happens like this. If you are charging, so if you are charging the capacitor, right? So what happens is, look, this is your 1 second, let's say 1 second, 2 second, 3 second, 4 second, 5 second, I don't know, 6, 7, 7, 8. Okay, now to charge some device, let's say you take 7 second, right? 1, 2, 3, 4, 5, 6, 7, 8. Actually 8. Okay, 8 second. All right. So when it is 8 second, it's fully charged. How much is the charge in 8 second? In 8 second, I don't know. Let's say this is like, let's say, I don't know. This is 8 coulomb. I don't know. This is just this is a real number, by the way. Okay, I'm just giving you some random example. This is 8 coulomb, let's say. In 8 second, how much charge is accumulated in the device? Let's say 8 coulomb, right? In 1 second, so how much charge is accumulated there? So what do you think this one? If this is 8, maybe this is 3. Look, 3 coulomb in the first second. In the second, in the next second, how many charge are accumulated there? Looks like this is half of this, right? This is 8, this is 0. Looks like this is 4. So do you understand? In the first second, how much charge is accumulated here? 3 coulomb, right? In the first second, 3 coulomb charge is accumulated there. In the second second, let me call it 2. In the second second, how much charge is accumulated there? 4. Now, can you guys tell me if the charge accumulated faster in the first second or second second?
First second.
First second, because in the first second, how much charge accumulated there? 3, right? In the second second, meaning from 1 to 2. From 1 to 2, how much is accumulated there? It's just 1. Just 1, because 3 to 4, right? Just 1. Okay? So if you do the third second, maybe, I don't know, this is, I don't know, 4.5. In third second, even if it is smaller, even 4 point, in next second, 2 to 3, the charge is one smaller, which is 4.5, meaning just increases by half, 0.5. So this is how it happens in charging process. In the beginning, it charges quickly, then it slows down until it reaches maximum, meaning 100% charge. This is 100%, which is 8 coulomb. That's the charging process. Does it make sense?
Yes.
So how do you represent that charging process mathematically in the form of formula? So how do you define that? How do you formulate that mathematically. This is how you represent the charging process, where Q is instantaneous charge. Q0 is the total charge. In this case, what is the total charge? 8. That's your Q0. Q0 is 8. So I'll come out, okay, and then 1 is 1, minus is minus, E is, what is, E is constant, okay? E is constant, is some value, 2 point something, right? That is your E. If you use your calculator, you find your E there. E is constant, it's the number, okay? Then T is the time, okay? So what is your R? R is the resistors in the circuit. Look at that. When you are charging your device, right? This is your device that you are charging. Then your device has the resistance, right? Your device has resistance. So this is your device. This is your device. Not only you have a capacitor in your device, but also it has the resistance. So you have R, resistance, and you have capacitance. So if you multiply this together, R and C, then you get RC, right? That's what it meant. Then what is this T? T is the time. Okay, let's plug this in. When T equals 1, by the way, you have to plug in the value of R and C, right? R in ohm and C in farad, right? Okay, 30 ohm, I don't know. And 3 microfarad, I don't know, okay? You have to change that to farad eventually, right? So if you have some resistor and capacitor in a circuit, then you multiply by together and put it here, like this. That's the number. Once you have the circuit, you know R and C, right? I'll give it to you. R and C, I'll give this to you in the test. R and C will be given. Then E is the number. It will be given, or you can use your calculator. Calculator knows that, okay? E is the number. Your calculator knows about it. R and C, I'll give it to you. 1 is number. Then Q0, I'll give it to you. Now, can you find Q based on the different data point, which is T? So when I plug in, okay, when I plug in T equals 1, right? This T equals 1. Let me clean this up. So when you put T equals 1 here, guys, this could be in the test, okay? Final. When you put T equals 1, oh, I erased this guy, sorry. When you got T equals 1, do you remember what is the charge here?
3.
3, right? So when you put T equals 1 and Q0 is 8, right? Q0 is 8. Okay. Now you know the value of R and C. I will give it to you. Now can you do this calculation? Q0 8 times 1 minus E, which is number, your calculator knows about it, minus 1. For now I put T equals 1 divided by RC, which is the number I give you. So you know everything on the right, right? You know everything on the right. If you calculate this guy, then what do you get? You get 3. That's your Q. That's your Q. Now, when T equals 2, what is your Q? If you remember, it was 4, right? It is 4. How do you get that? Put T equals 2. Put T equals 2 here. And instead of 1, so change this to 2 now. Again, you have the same RC. You don't change this guy. In your problem, it's given, it's there. You don't change them. So RC is there. Then you just keep changing this T. If you keep changing T, then you get different value of Q. And when T equals 2, then what will be the Q? You happen to get Q equals 4. Does it make sense?
Yep.
So when T equals 8, let's say, when T equals 8, what do you get? What should be your Q? Q should be
8.
8, right? Now suppose your T is, I'm trying to ask you something here. So if I give you T equals RC, suppose this is your T equals 1, right? This is your T equals 8. Okay. When you multiply R and C, so how much you get, let's say? When you multiply R and C, you get 4, let's say. I don't know, 5, okay? I don't know, 3, let's say. When you multiply R and C, you get 3. This is your time T equals 3, which is exactly equal to RC. When you multiply R and C, you get 3. That's what I meant. Maybe your, I don't know, your C is 6, your R is 6, and C is 1/2, right? When you have R is 6 and C is 1/2, then what do you get? What is the product of R and C? 3, right? That's what I meant. Okay. When you have T equals R and C, what do you get from here? Can you help me here? What is your Q equals? Q equals Q0, right?
Times 3.
1 minus E minus RC. Now your T is RC. Your T is RC, and you have divided by RC also, right? That's what I meant. So what do you get from here? 1 minus E to the negative 1, right? This is cancel out. You get 1 here. This happens to be, what do you get from here? Minus 1 over E, right? This guy is minus 1 over E. So then you have to add minus 1 over E to 1. So what do you get? Q0, right? Q0, which is equal to Q, right? Q equals Q0, 1 minus 1 over E. That's what I meant. Guys, what is this guy here? So 1 minus 1 over E. This is constant. This thing is constant. So do you guys have calculator? Can you calculate 1 minus 1 over E? In your calculator? How much you get here?
.63.
0.63. So equals 0.63 times Q0, right?
Yes.
So how much, if Q0 is 8, how much is it now? What is the Q? So if Q0 is 8, how much is your Q?
5.04.
5.04. So let me tell you something very interesting process here. So if you know R and C of your circuit, right? See, if you know R and C of your circuit, then you can tell me how much time does it take for your capacitor to charge up to the amount of charge equals 5.04. How much time will be required? RC. In our case, 3 seconds. In 3 seconds, this much charge will be charged in the capacitor without even charging. Do you understand? Without even charging the device, you can claim that in the time T equals RC. See, I put the T equals RC, right? Do you see that? I put T equals RC here. That's what I did here. When I put T equals RC, your device will be charged 63% when the time equals RC. Now, if you want to charge your device, right, then calculate the value of R and C, multiply them together. So, which is in our case 3. During that 3 seconds, your device will be charged by 63%. How cool is that? So, without even charging your device, if you know R and C of your device, if you know, because they are constant, right? Once it is there, it's there. You cannot keep changing your R and C, because once you have your cell phone, right, you cannot change your capacitor. You cannot take anything out from there. Once you have it, you have it. Once you have R and C, then you can tell me how much time it will take to charge your device by 63%. To charge the device by 63%, you need to charge during, for this much time. The time equals RC. In our case, this is 3 seconds. In 3 seconds, your device will be charged by 63%. Okay, so that RC is the time, and that particular time in which your device will be charged by 63%. That time is called time constant of the circuit. This circuit has the time constant, and that time constant is equal to R times C. In our case, that time constant it happens to be 3 seconds. Okay, what is the time constant? Time constant of a circuit like this is the time in which I'll get the charge in the device equal to 63% of the total charge. So it means your device will be charged 63%. It's not 100% charged. During that RC time, your device is just charged 63%. Is it clear now?
Yes. I have a question.
Sure.
So is RC only equal to T at that specific point, or is it always equal to T?
No, this is tau. This is not T, this is tau. Okay. This is
Oh,
T equals tau. Okay. This is a very good question. T equals tau. So when your time is equal to RC, right? When your time equal to RC, okay, in this case T equals 3, okay, so now you don't call it T, you call it tau. At that point, your T is tau, you call it tau,
oh,
okay. That is called time constant. Tau means time constant, okay. Does it make sense?
yes.
Good. Discharging happens this way now. If you want to discharge some device, right, how does that occur? The discharging occurs this way. So in the beginning, it discharges quickly. See, in 1 second, suppose this is your 8 again. This is your 8. In 1 second, I don't know how much is the charge here. I don't know, 6. Maybe this is 6 in 1 second. In the next second, how much is there? Maybe, I don't know, 5. I don't know. When the discharging happens, in the first second, it discharges quickly. In the beginning, your device discharges quickly because in the first second, how much is discharged? In the 1 second, you get discharged from 8 to 6 by 2, right? It discharges by 2. In the next second, from 1 to 2, it discharges from 6 to 5, just 1. In the beginning, it happens quickly, then it becomes slow and slow and slow and slow and slow. Discharging rate is slow and slow and slow. Rate, I'm talking about discharging rate, becomes slow and slow. Does it make sense? Then how do you represent that discharging in the mathematical way, in the mathematical formula? This is how you represent in mathematics. Okay, in this case, now again, it's the same circuit, right? Same circuit, RC. If you know RC, then what is, if your T is tau, meaning RC, right? When T is equal to RC, then what do you get? Can you help me here? What is your Q? Q equals Q0 divided by, so what do you get here? E to the negative 1, RC divided by RC is 1, then negative 1. E to the negative 1 is 1 over E, right? Meaning you get Q0 over E. What is your 1 over E? 1 over, it means 1 over E times Q0. So can you tell me what is your 1 over E?
0.36.
0.36, meaning 0.36. 0.36 times Q0, right? Look, what I'm trying to conclude here is when discharging in the amount, let's say, what is your RC in the previous problem? RC was 3, right? So in the time equal to RC, which is 3 in our case, how much will be discharged? Only 36% will be discharged. While in the case of charging, during that time, how much will be charged? 67%.
63%.
63, right? In the same time, charging happens 63%, but discharging happens 36%. So there are some numbers missing there. If we add 63 point something and 36 point something, that happens to be 100%. See the magic? Okay, 36 point something and 63 point something, that add up to 100%. It's weird. It's amazing, right? So during the time equals RC, 63% will be charged. During the same time, RC, 36% will be discharged. Okay, so that time is called time constant and is equal to the product of R and C.
Mm.
Does it make sense?
Yes.
So if it does, then I'm going to close this up. So I'm done further. This is one of the application of capacitor. This kind of circuit is called, by the way, RC circuit. Okay, if you have R and C circuit, then this kind of circuit is called RC circuit, and these are useful. Okay, so this is one of the examples how they are used in medical application.